In this video, I want to show you how you can create a Voronoi pattern in 3 dimensions, so something like this or this kind of thing. So let's get started. First of all, if we want to create a 3-dimensional Voronoi pattern, we can use the component Voronoi 3D here that asks you for the box and a population of points. So to create that population of points, I need to define a boundary, and to do that, I need to create a box. So this is the box. Rectangle, I define a rectangle. This is an XY plane. This is a box. Okay. Now I can go to vectors menu under the grid palette, draw population of points in 3 dimensions. This is the region, but I want to drop some random points into that. And then I'm going to drop, for example, 60 points, that box. And here I will say, okay, this is a population of the points, and this is the bounding box. So here we go. That pattern actually resembles the aquatic stadium in Beijing Olympics, if you remember that. Now, in the next step, I want to get this pattern, let me increase the number of points here. I want to kind of get these lines that are the lines of the bubbles intersecting the faces of this box. So what I'm going to do, I'm going to just get vrep deconstruct vrep, and I will get the box. And then here I will get 6 faces. So then I just call list item. I want to get 4 faces of this box. And here I'm going to give it 4 index values. I suppose 1, 2, 3, probably should be the index values. Let's see, this one, and this one. Yes, right. So these are 4 faces. Just need to turn these off. Okay. And now there is a component which is called vrep. Right here, well, we can go to the intersect here, and I want to get the intersection of, oh, here, the vrep. Well, that's, I mean, I kid in, but it didn't work well. So I'm going to get the intersection of these cells and all of these 4 vreps. And if I just pick this, it will just find the intersection with one of the faces. So I need to kind of graft the cells. So then each of these cells will be in separate branches, and then they will be analyzed versus these four faces, and then I can get the intersection curves of all four curves. Now in the next step, let's just create one of those other perforated patterns. So I will drop scale, and here is the geometry. And then for the center points, I would just say polyline center. And I will get these fours. And here's the center. And oh, sorry. I want I don't want the center point of the faces, but the curves, the polylines. So now I can give the factor. There we go. So there we go. And if I just continue and say boundary surface and give this curvature and this curvature, let's just I'll get the surface. In order to a little bit make these forms a little bit more nice and like curvy, I can call fillet component and say, okay, get these curves and fill them by a number like 5 to 5. Example, this is the radius, so I can increase it. And then you see, oh, well, maybe I can increase the maximum, so I can just go with 10. All right, so if I increase it, I'll get a more bubbly shape. And then here I can, instead of this one, I can say scale this and find these curves centers. Oh, that doesn't get that curve center. So let's just go with this. And then sometimes this center points gets it just gets the actual polylines, but not curves like this. And here it's just so these are this curves, these are these ones, and now when I use the boundary surface, just gonna call. And here we go. Well, I see that there is a kind of notification here. It says planar surface routine returned no results. Actually, we have the results. If you move your cursor over the outputs, it says you have 84 outputs, and that's because the way that the boundary surface component calculate the surfaces, the surface definitions. So in this case, you can try, for example, loft. And do it in this way, using loft, so then you're not going to get any error. Now, this is how I got the surfaces. Well, actually, this is also part of it. We can just do a little bit of housekeeping, cleaning up this. So this is the surface. And now if I want to extrude this loft, to give it a thickness, extrude. So this is the base. So it asks for the direction. Can go with amplitude. This is the vector. And I want to it this. And about the vector, I can go with 2-point vector. So one point can be the center point of each face, and then the other point can be basically the center point of these geometries. Okay, so in this case, where is that? So we have the center points of these geometries, and then the next point can be the center point of each facade. So in this situation, I will just say, okay, let's call rep, construct rep, and I will deconstruct these faces. I already have these faces, so I will just go with center, polyline center, and I will get four centers, which are the four centers of each shape. And now you will see the extrude component will extrude each part based on the center point of each facade surface, and they're in the same order. So now you see that you can get like this kind of pattern. And now if I play around with the number of points, I can also increase it to 200. If I increase them, then we should get probably a different pattern. Or, for example, by increasing the height, I'll get a different pattern. So this is it. So this is the next pattern of the next typology of Voronoi forms that we can create using Grasshopper. The other thing that you can do when using this three-dimensional Voronoi pattern is that when you look into BREP intersections, you can basically call the BREP intersection and connect just cells to both BREP A and B. Then what you would get is the linear structure, the linear edge of these patterns. And then later you can like add like a pipe component. This may go crazy. And get this kind of structure, which might be nice. So let me just reduce this. Using this situation, the file will get really heavy and just reduce it to something. Okay, I mean, here you go. So you can get like this kind of comb structure if you're interested. There are like many other crazy steps that you can do, like designing a strip across these lines, or like you piping them, extruding them, or like using these lines as a as an axis for extruding a particular profile and creating diverse geometries.